All right, welcome everyone. We're on chapter 22 of Welding Principles and Practices book. This one particularly pertains to gas metal arc welding practice. We're going to walk through the chapter, PowerPoint together. Chapter starts out on page 728. So, if you notice in the first couple classes, I was really big about telling you bulleted points, and this is a hot topic item. And as we start going through more advanced courses, I don't really do that anymore, okay? Part of the reason why is I feel that it's important that if I told you throughout the whole entire program, so this is a bulleted item, this is a bulleted item, then you're going to kind of know where the test stuff is going to be on. And you're not really being able to critically think, hey, that's an essential variable. All right, what he's talking about, this is kind of important. You know, let's look at this, so forth, okay? And even now, I think I take a few times, there's a few times I'll go in there and I'll say, you should really know this, or this is important. Basically, I don't think it's a bad thing if you were to print out the PowerPoints or just put them in and take some notes. Write some things that we're talking about. If I go into a detail about it specifically, more than likely you could possibly see it on the test, so forth. I want to make sure that your knowledge is broad and that you understand it, that you're not just taking the test and going straight for the test. If all we did was put the same 10 questions throughout the entire program, just to make sure you got the same 10 ones right the whole time, it's not really teaching you anything. It's just basically teaching you how to take a certain test. And that's not what we're here about, okay? So we're going to walk through chapter 22, keeping this stuff in mind, moving on. The objectives. All right, operating variables that affect weld formation. Factors that affect operation of arc and weld deposit. Sound welding of good appearance results when variables in balance. Necessary to become familiar with all variables. Okay, so we're going to start figuring out what's important and why is it important. So, for example, DC electrode positive, okay, generally used for gas metal arc welding. It provides maximum heat input into the work, allowing relatively deep penetration to take place. Also assists in the removal of oxides from the plate. Low current values produce globular transfer of metal from the electrode. So, on carbon steel shielding gas, must contain 80% argon to produce a true spray transfer mode. So we'll get into the different modes of gas metal arc welding as well as we're going through here. And we'll talk about the gases needed. I don't remember if we did in chapters 21 or not. If we went into that, I believe we touched on the basis of it. Yeah, we did. We talked some about the metal type, the gases, argon, helium, and so forth. So this should just be, you know, kind of building upon that as well. All right. So here we are, DC electrode positive. So your workpiece or your ground is a negative. Positive, good penetration values. Flow of the positive to the negative electrons. Okay. This is a globular transfer where it globs up, drops down, resulting being in this and showing here. Good formation, nice weld appearance on the top side, so forth. Okay. DC electrode negative, limited use in welding for thin gauge materials. Greatest amount of heat occurs at the electrode tip. Wire melt-off rate is a great deal faster than electrode positive. Penetration is also less than with positive. So basically what we're saying here, well, real quick, let's finish this. Arc's not stable at the end of the filler wire. 5% oxygen added to the argon usually, so forth, okay? Basically this is going to be for thin gauge materials, okay? Right here, what we're looking at, very low penetration, Okay? Resulting bead is a nice high crown piece, but not a lot of penetration. So this might be something that we're looking at if we're dealing with like a very thin gauge material, sheet metal and so forth. Then yeah, like decking, putting pieces together, cutting out holes and welding them up. This might be what we want to do. We might want to switch it over to electronegative instead of positive, go from there, so forth. However, usually, I'm going to show you several techniques welding with DC electropositive. It's where you can just back your voltage down and usually manipulate that weld pull to where you're not constantly switching machine back and forth, okay? Alternating currents, very seldom used in gas metal arc welding. Oh, excuse me, I'm sorry. Moving forward, combination of both electronegative and electropositive polarity, rate of metal transfer, and depth of penetration. It's kind of in the mean. Some use for welding of aluminum. Okay, mainly most machines we're going to use will be, now they've got an electropositive or electronegative, and they'll have a pulse on them. Some of the newer machines, or you may be running a spool gun with just a straight feed, and we'll learn how to manipulate by the hand as well. Hand-eye coordination and travel speed as well. Shielding gas. Argon and helium, first used for gas metal arc welding. They continue to be the basic gases. Next to, I would also say CO2. Remember, you can have argon, you can have 75-25, 75% argon, 25% carbon dioxide. Much prettier weld puddle than just carbon dioxide. Some materials can be used with carbon dioxide. However, that's not exactly what we want all the time. Okay? Argon's used more than helium on ferrous metals to keep spatter at a minimum. It's also heavier than air, so it's better weld coverage, especially a little bit of a cross draft situation as well. Okay. Helium's added to argon to increase the penetration. Helium will take the heat value up a lot. It'll make it a lot hotter weld puddle. Okay. And that's if you're even welding, you can use helium when you're doing plasma arc cutting or plasma arc welding. You can weld helium and it'll boost your temperature up quite a bit actually. But usually it's a lot more expensive gas. So it's not always used, but there's always rare situations out there. Certain metals or so forth, or even certain filler metals may require it to be helium. Okay? Carbon dioxide has the following advantages: low cost, high density, resulting in low flow rates, less burn back problems because of its shorter arc characteristics. However, you're not going to find a lot of CO2 out there. And to be honest with you, we're walking away from CO2 because it's not nearly of a nice weld appearance. The electrical arc stability is much better and much more controllable using 75-25 than it is running 100% CO2. 100% CO2, it's kind of the bottom of the barrel gas, so to say. It's kind of like the stuff we scrape off the bottom. It's not necessarily the highest quality. And there can be a great difference as a fluctuation as well. I've had CO2 bottles that one would be okay, switch it out, and the next one, you didn't change anything other than the gas. It just seemed to have a whole bunch of impurities and junk within it. Really rough on the regulators as well, and so forth. So we walk away from CO2. Most shops or most places we're going to be welding going to be at least 75-25 or argon or so forth, okay? Specific metal recommendations for aluminum alloys. So this is an important thing to write down in your notes right here. It's just an overall good thing. Good bit of information to keep. So if you're welding down the road, be like, hey, what was it? I haven't done magnesium, but I'm going to try it a little bit. What did I need? Oh, argon, okay. So aluminum alloys are argon, magnesium, and aluminum. Can be 75-25. Again, sometimes you can use different ones. Which one's preferred? Argon. Straight argon with aluminum. Okay. Stainless steel, at least 100% argon, usually argon plus oxygen or trimix like we talked about in the last one. Okay, so forth. Deoxidized copper, 75-25 is preferred. And then low alloy steel, argon plus 2% oxygen. And this can also depend on the gas metal arc welding process as well, whether it be short circuit or mode of transfer as well, whether it be short circuit, globular, spray arc, or what. Okay. Here's another good example. Dun, dun, dun. All right, joint prep. We're on page 730. Okay. The joint design should provide for the most economical use of filler metal. Also make sure that you're getting complete fusion within your joint preparation and joint design, okay? Correct design, the job depends on the type of material, thickness of material, position of welding, welding processes, results, so forth. Technique, type and size of filler metal, absolutely. The arc and gas metal arc welding is more penetrating and narrower than arc and shielded metal arc welding. Therefore, smaller root openings may be used for groove welds. And you know, this can be a very big stipulation as well. By the time you get in here, make sure that you and I have had the talk in the shop about differences between root face or lands that we put on for different positions. So for example, when I'm using wire, especially with short circuit mode transfer, doing an open root weld joint 3/8 butt joint V-groove, flat, I'm going to put just a little bit heavier of a land on, maybe 1/16. Horizontal, I'm not going to put, I might just barely touch it, not nearly as heavy of a land. Vertical, I'm going to put a little heavier land on, 1/16. And I'm also going to take the root opening a little bit tighter too. I might take it to 3/32 versus everything else I'm going to run at 1/8 of an inch. Now welding it overhead, I'm not going to put any land on it because I'm going to have a problem getting that penetration up in there as well. Okay? All right. And so right here it says 100% penetration may be secured in 1/4 inch plate and square butt joint welded from both sides. As we're reading through wire, a lot of machines, you're going to be able to flip up the cover of the machine as you're reading the technical data. It's good to do. But you're going to see, it might say 200 amp machine, okay? Millermatic 200. It might tell you it can weld 1/4 inch in one pass. Okay, that doesn't mean you have to weld 1/4 inch in one pass. What I want to stress upon you the entire time in this welding program is you weld to a good weld bead. I don't care how heavy or how thick it is. There's things that matter a lot more than doing a weld in one pass. Okay, number one is fusion, penetration, good weld is acceptable. You weld to the weld puddle and the performance of the filler metal and process you're using, not to what the machine says it can do. Okay, so if it takes you 3 passes to weld a 1/4 inch plate, I would rather see that, and most manufacturers, company owners, and your employers are going to say the exact same thing. A good weld is much better if it takes you an extra minute than doing it all in one pass, running super hot, it distorts, it warps, and then you have a huge problem. Cut it back apart and start all over again, okay? All right. Joint preparation, no root face recommended for 60 single or double V grooves. So here we go. Here's back into it. And we get into the shop, like I was telling you earlier, I will show you what I prefer, and a lot of it's going to depend upon heat values, what mode of transfer we're using, and then also how's gravity working for me. Naturally flat, it's going to sink in, so I want a little bit heavier land. I have to think about that. Versus overhead, I'm going to be fighting it, so I need no land, no red face, and I want to be angled back in, pushing it in, kind of keyholing and making sure it's fusing along that top edge as I walk along it, okay? Plates greater than 1 inch should have U-groove prep. They require less weld metal. Root face thickness should be at least Most of the time we're not going to be a lot of 1 inch on gas metal arc welding. We'll be seeing a lot more of that with flux core. So therefore, fusion's not really the issue with flux core that it is with gas metal arc welding. So this is just one comparison, all right? And remember, we don't know how thick this material is or anything else. What I want you to focus on is how to weld to the correct weld. At this point, we've been through it. You know what you're looking for. You can see problems. You're starting to see discontinuities. If you need to take it back to 65 degrees or 75 degrees for wire, do the same thing. It literally takes just a second longer, okay? And then as you gain more and more skill, this becomes much easier. Do not hang up on this at the beginning. As you get more and more practice, you can start cutting your angles, being a little bit steeper. You know how to get away with a little more things. You've got a little better manipulation, so forth, okay? Joint preparation. Multi-pass welding is easier since the absence of slag ensures easier cleaning. Okay, so here's something that I really stress. And I have seen people that have taught me how to weld have problems with this. I personally have had problems with it. Almost every welder I know has had a problem with this weld. So I'm going to give you a side profile of the weld. Okay? So as we're gas metal arc welding this together, we put our root in, okay? And then we want to go, usually what we think is since there's no slag, we don't have to clean it. Oh, we might want to wire wheel it and that's it, okay? Well, usually what happens is we'll get here, okay, we weld it up, and then we go to bend test that. And this is where bend testing is really pretty amazing. What you're going to see happen, and I've seen it on mine, and I've seen it on, like I was saying, the welders that help teach me how to weld as well. What happens is you're going to see these welds start breaking right here at the toe of each one. Okay? Now if you notice that they're a mild steel filler metal, okay? But when you open up that wire, what does it look like? It looks like copper, right? So there's a coating on that wire that prevents it from rusting, which it has to. Otherwise, it's just going to be one big ball of rust. And then we've got oxides and rust within our weld. We don't want that. So what they do is they coat it in this coating to help prevent it from rusting and corrosion. So as we're welding this, guess what happens to that coating? That weld, that silica specifically, what it does is it comes out here, say it's here, is it sits and it solidifies right here on the surface of the weld, at the weld pool, right? Because that's what it is. When anytime we melt something, the impurities always come to the top of the weld puddle. That's the whole reason for welding, is so that it comes to the top and to the surface. If we need to, then from that point, we grind it off, clean it, and so forth. So exactly with that. When we are doing multi-pass welding, especially if we're going to bend test it, and it's a critical weld or holding temperatures. So I do this even on a fillet weld. If it was like on a building, a skyscraper, and I was welding it with wire, and it was going to stay in place, I would grind the top off. All groove welds especially I do. I want to come in here with the grinder, and I want to take the top just layer off to where it gets down to good, clean, shiny white metal. So when I say shiny white metal, you'll notice that when you clean it off with a wire brush, a power wire wheel, it's going to be a gray, okay, almost a silvery. But I want you to learn how to do this a couple times first. So take it and clean it with the wire wheel. You'll see it's silvery, kind of grayish, right? And you see a nice weld ripple pattern. I want you to take a grinder, and I want you just to skim the top surface, and you'll see the two different colors of the shades of gray to a white metal that I mean. It goes down almost to a pure white metal, okay? That's what we want to get down to every time, okay? Especially when we are layering multi-pass welds, and I'm using a V-groove because it's most prominent in a V-groove situation, okay? So right here on this root specifically, usually you crown up high like this. So in this case, we want to come in, we want to take our grinder, and we want to knock this down in to where it's nice and flat, okay? So then we have a nice flat where we can get in here and tie into both sides. All right? So we brought our grinder in, we cleaned it up here. So then our next weld pass we're going to put in from here. Say we weld from here to here, okay? Now if you notice, this gap right here is going to be a little bit rough. So again, in the time, in the gaining the experience to be efficient and time consuming within our job, do I need to grind this entire weld thing back down? Not at first. But say I want to come in here and I need to put a weld pass in from here to here. I'm going to grind down from here to my high point. And how this helps me at the same time is if I put a groove right here with my grinder in, okay, then this is also going to give me a target to shoot for when I'm welding. So that's going to tell me where my high point is. Then I'm going to weld from here to here. Now I can come back and say I don't have to grind the whole thing at once. So I'm going to do the same thing here to here. So I'm going to come in and grind down from here to here, weld that. Same thing, grind. See what I mean? Okay. We want to make sure that everything we're welding over has been ground, but we don't have to clean the entire thing down every time. Okay, that takes up a lot of time that we have to start learning how to shave some time and be efficient, especially with MIG welding. Now this is on thicker material. On really thin material, you know, say up to 3/16 of an inch for the most part, 8 to 3/16, we're going to be able to do it all in one weld bead or one pattern. Also depends on what the weld joint is as well. So if it's an edge joint, then yeah, we're going to get the whole thing in one pass more than likely. We may not even have to do more than one pass or a multi-pass weld, okay? Saves us a bunch of time there. But yeah, we start looking at the essential variables, what we need to do, what's important, and so forth, okay? All right. So we talk here of backed up to prevent weld from projecting through the backside. You can use, so especially with copper, copper's a really good one, or brass specifically. I used to have a big brass bar, a big brass plate that I could put there. I machined it up to where it's a flat face, drilled and tapped it with a threaded handle on that. I could hold it underneath of my groove plate. If my gap was wide, especially really wide, and I would use it a lot on flux core specifically, but if my groove's wide and I've got like a 1/4 inch root opening and I want a full penetration weld but I'm worried about it drooping through, I can take my groove weld like this and I put that brass plate or that copper underneath of it and it'll hold it there. Basically it's like a backing bar. Or a backing bar or a chill ring, and it won't fuse to it, it'll just lay against it and solidify, okay? And I would just kind of move it along that weld joint as I was welding along. And that kind of became my backing strip or my backing bar. You can do it in ceramics,